a prep for all of us to face any outbreak, and especially with Hajj and Umrah, we every year expect something to happen. So as a national team, we should have all these set and ready to be used. And with that, I am coming to the last slide, and if you have any questions, I will be happy to entertain it.
Thank you, Dr. Fatma, for a wonderful talk.
Thank you.
My question is a logistical one. We know that an NGS run generates enormous amount of data.
Yes.
Even exome-specific sequences or sequencing generates lots of data.
True.
Do you think there's a system whereby we could utilize and justify, because part of the problem is justifying the cost, is that we could link different researchers and different practitioners with a consortium or a database, or for example, like the Saudi Genome Project, so that we don't waste all of this enormous data that is being sequenced. I visited an institute in Groningen in Holland, and they had a wonderful setting where they had the clinic where they brought in the patients, offered them to do a physical exam, sequence their genome. So it went to the lab, to the college.
Yes.
And people who did research there then stored their data in what they called Lifeline, which is like the Saudi Genome or their genome project.
Yes.
And in that way, the costs came down rapidly. You have the information stored.
True.
And you have students that work on, and researchers that work on the sample. So I think you need that kind of a triangle system.
True.
Do you think it will, because you want it to be readily available here?
Exactly.
Do you think it could stand alone, or it needs such a system?
Yes. As far as I know, when it comes to Human Genome Project, as you all know, CACST has started 13 laboratories in Saudi Arabia. Different areas. I know in King Faisal we have one. It's about Human Genome Project only. So they are working on it, and they have the budget. They already bought the machine, and they are already having trained staff. But the other thing you are saying is just to have it readily for everyone. I think it should be a core facility in every institute, and this is a must. Even there are two lines we are talking about right now. You have a core facility that's even for researchers, and you have a bench top in the clinic itself. This is kind of a common practice in most countries where they have a bench top, because it's not going to be something big or costly, because you will get the results easily if you are looking at especially microbial, because it's going to be different than the human genome. Human genome is huge, and you will get tons of data coming out of it, and the pipeline is completely different. As I said, in King Faisal, we do have for the Human Genome Project. I think King Saud, they do have it with part in agreement with CACST. I know King Abdulaziz University, Taiba University, so they do have the whole genome, the Human Genome Project.
Even for microbial genome, it's still a lot of data. So you could actually be, gathering information on a particular strain in Saudi Arabia. So
absolutely,
I think it is important to connect such work of any work that generates sequences and identify sequences into some sort of a combined, data bank that other researchers could benefit from. And I think that is the real justification to go to our bosses and justify. What we have in King Saud University is islands, people who work on their own, and there's no really true connection between them, or the hospital, or the Saudi Genome Project, with the exception of maybe Dr. Al-Qahtani's lab here in King Saud University. But as I said, we think we need to think of logistics when we're talking about genome sequencing, even of microbial or any other organism. And thank you very much for your talk.
You're welcome. Thank you. We always we want to work together as a team, and we find it is the way to collaborate. And as you said, the machine can be used by so many, and this is the way to go. It's always collaboration, generating a database, and I rely a lot on the national lab, which is led by Dr. Ali Khiyami. I think this is his job to do at least a national lab, and they should have the NGS facility. When we talk about a national threat, that's something different. It should be available. Anyone can use it because it's going to generate the data, which is a national data accessible by everyone. Also, the CDC, I think they are tagging along as well. This is their responsibility when it comes to sharing data and be the hub for next generation sequencing. Anyone is welcome. And instead of depending on some scientists and some people who is hard to work with sometimes, but I think if we step it up to a government, or I think the national lab will be the best choice.
Thank you very much, Fatma. I just wanted to comment, but you are faster than me. You mentioned it already, the National Bank for NGS for outbreaks.
Yes.
Because this is coming from the UK, this is the British example. They have a national lab in the Public Health England,
Exactly.
only for NGS on outbreak isolates.
Absolutely.
And they report the data maybe within 2 days or something.
Yeah,
But
this
you
is
already
kind of
mentioned the national thing.
It is kind of a common sense, and we are way behind, but we are prone to infections any time. So we have to be ready. We don't want to have another corona to wake us up. We, I think, got the lesson and lesson learned, and now it's time just to be prepared.
Any questions?
Any more questions? Yes.
Thank you, Dr. Fat.
Thank you.
Thank you, Dr. Rafat, for this very nice, interesting presentation. So my question is this next generation can be used to diagnose or detection of latent virus infection? As we know, the conventional immunological, serological, and some molecular methods fail to detect some latent viral infections.
Yes. Well, if the sequence is there, you will get it sequenced. If the viral present, you will get it sequenced. But again, that doesn't eliminate the other tests. You can go parallel, basically. Sometimes you are working with unknowns. You want to know the results immediately, but the routine lab test should take its place. You are not going to hold everything and rely on the NGS because it's a help. But at this point, we are at the validating point and error and trial. Yes? Well, I can't hear you.
I mean intracellular viral latent infections, such as cytomegalovirus,
Yes.
Epstein-Barr virus.
Yes.
This virus take 10 years
Okay.
inside the cell. Is this technology can help to detect or diagnose these viral genomes?
If the viral titer high, I'm sure you will pick it up. If you open up the cell and get the sequence out, why not? That's how I see it. I might be wrong, I don't know, but this is theoretically I'm talking, so
Thank you.
thank you. Yes.
Thanks for your nice talk. Just I'm asking about the error rate that you accept normally in the reads, because we know retrieving a big data, it can be a challenge. So
Yes.
from your experience, to which limit you accept the error rate from the NGS? Because it's been known already that there is some error rates with the reads that you retrieve. So from your experience, this is a question that is...
As far as I remember, the e-value should be like point, I think, 5 to the -5, I believe. That's, if I remember, the e-value for the error rate. Also the read and the coverage. How many times your sequence got covered and got the read. So that will help you, because there are so many criteria that you need to have to validate your sequence and pass the quality check, because there are checks. Either this sequence is right or it's just a random. So it has to be so many times, at least 80 times, and when you align, it has to be like the contigs length. There are so many criteria. Again, it depends on the microbe you are looking for. But that's only because there is a quality check. And that's those things that I remember right now. So, okay, thank you guys.
Thank you very much. I need to ask you something, I mean, outside
Sure.
of the lecture. I know that you are a vice dean for, and also the founder for FIDA,
Yes.
Women's Health Organization. I mean, maybe somebody in the audience, they don't know what's Rufaida, so can you give us just a talk, 3 minutes or 4 minutes about Rufaida?
Okay, well, we have started Rufaida Women's Health Organization. Basically, the idea behind Rufaida is we have seen cervical cancer cases in Saudi Arabia due to HPV infection, or it's a sexual transmitted infection. And ladies, they always come with a cervical cancer in late stages. So we started to do awareness just to tell them about the sexual transmitted infections. And we have noticed they have no clue about women gynecological health. And so we decided, okay, instead of focusing only on cervical cancer, we know ladies, they need help in different area. So we decided to do the Women's Health Organization, where it tackles so many issues regarding women. It tackles like the healthy lifestyle, the self-confidence, the mental health, the maternity health, even teens, we include them in this organization. It's just a newly established. We started last year. So we have a Twitter account. I think that we are active at Twitter. So why we picked Rufaida? Anyone knows what Rufaida means? أنا بتعلم من دكتور يزيد. He's asking questions, so I'm gonna ask. صحابية, Rufaida al-Aslamiyya. So we picked Rufaida because we believe Rufaida is a great idol. Rufaida al-Aslamiyya هي أول ممرضة في الإسلام. She had مستشفى ميداني. She was participating during the war, and she was with the team during that time. And so this is kind of a message that women empowerment is very important, and women being a part of the society is very important as well. We should not be passive. We are part of the society, and every woman should participate in everything she can. And also Rufaida, the name itself in Arabic mean malja or shelter or sanctuary. So we wanted this organization to be the hub for all ladies. They have any issues, they would come to Rufaida and get their questions answered. So that's briefly about Rufaida. I would love to talk forever.
Thank you very much, Dr. Thank you, thank you. It's very nice talk, Dr. Fatima. The next speaker will be Dr. Naif Al-Harbi. Dr. Naif is a graduate from Oxford University in UK, and he is associate research scientist in virology in King Abdullah International Medical Research Center, National Guard. He is a member in different society, and also he have a huge number of publications. Welcome, Dr. Naif, for your talk.
Thank you very much, Dr. Al-Harbi. Assalamu alaikum. مساء الخير جميعا. Well, my slide is MERS-CoV overview, so I'm not going into details in any of the aspects, so I try to just touch on different sides of the MERS and MERS-CoV virus. And thanks to Dr. Fatima Al-Hamlan, she already introduced some of my talk. So the beginning or the story of MERS-CoV. It started by the patient that Dr. Fatima mentioned from Bisha. So that patient traveled to Jeddah, Dr. Sulaiman Faqih Hospital, and was experiencing respiratory illness, which led to severe pneumonia. And Dr. Ali Zaki took the sample, tried to figure out what the sample was, and he ended up discovering MERS-CoV, sending the sample to Rotterdam, Erasmus Medical Center in the Netherlands. So actually, when you said 2 months is long, it's not long. Given the situation that I'm seeing now in Saudi Arabia, it's very difficult to do that kind of research. So I think it's an achievement from him, regardless of the controversy that went with it. But identifying a virus, that's something amazing. And Albert Oosterhuis as well, the Dutch virologist, was also put as an inventor for the same virus. And we know Albert Oosterhuis is called virus collectors. He has identified more than 40 viruses so far. A few of them, maybe less than 10, are related to human health, but the rest are veterinary or insect viruses. So around the same time, that was Bisha isolate, and it's different from the EMC, Erasmus Medical Center 2012 isolate, and I'm going to come back to that later on. But around the same time, there was a patient from Qatar was hospitalized in the ICU in St. Mary Hospital in London. And because of the report from the Saudi patient, people will start looking in the British health provider, they start looking for the same virus, and they got the same sequence. And then retrospectively, people went into an outbreak that happened in Jordan early that year, early in 2012. And going back to the archived sample, they identify MERS-CoV. So although it was first identified in Saudi Arabia, in fact, in nature, it happened in Jordan before that. Coronavirus, or beta coronavirus, is the section of that family. It has 4 different groups. Group A, which has human COVIDs, Group B, which has SARS, and then Group C, which has the MERS-CoV. Group C is the only, MERS-CoV is the only human virus in Group C. And it's double-stranded RNA, 30 kbn length virus. When we look at the genome, we see here the overreading frame 1, overreading frame 2. And based on the overreading frame 1, there was less than 80% similarity between this virus and the other beta coronavirus in Group C. So that's why it was distinct, less than 80% homology. Those operating frames both gives unstructural proteins, and then we have the S-spike protein, we have the matrix protein, the nucleoprotein, and the envelope. And the virus is not, and the envelope protein here. So no wonder people start questioning bats at the early stages of this, because it's related to bats, similar homology, although it's distinct, it's still in the same. And most of the coronaviruses are found in bats. But later on, well, not very soon enough, I mean, people examined camels in Oman, and they found this seropositive, camel seropositive in Oman, which switched the looking for the origin of these viruses into camels. But that was only seropositive data. And then when people went, and these data are in Saudi Arabia, when people went into archived sample, 70 to 90% of archived camel serum are positive for corona. And these coming from 1993. Later on, that 2014, or early in 2014, there was this paper from this university showing that the virus exists in Saudi Arabia. Those 2 figures here, this one ELISA, one RNA detection. So across the country, there was the ELISA data and qPCR or RT-PCR data showing that the virus and the seropositivity is there in this country, and it's distributed geographically. And then from that, people went to Africa looking for the virus in Africa, or the data, or the camels in Africa. They found the seropositive camel serum in Kenya, in Somalia, East Africa, and different countries. So this is just an example of some publications. But also from the genetic sequencing, we can, it's easily, you can, even if you are not a bioinformatics or you're not an NGS person, you can tell these are the human isolate and the camel isolate coming in the same tree. And one of the interesting story is this Bisha strain is different from the EMC strain, although it's the same virus. Azeki passaged the virus in viral cells in Jeddah, then send it to Erasmus, and it's a completely different virus. So it's intentionally induced, well, not intentionally, but induced mutation. Sorry, I'm fasting today, so if you keep with my dry throat. So now I think we have a model. So the virus may or may not originated from bats, went into camels, but we have data that the same virus here is the same in human. And in human, we have asymptomatic patient or symptomatic. So the asymptomatic patient could transmit the virus to human, especially in the healthcare settings. The bad thing is still under investigation. And when it comes to camels, this country, camel is important in this country because of the big number and because of the social and the cultural and the food industry of this. So we have one camel for every 22 people. Ministry of Agriculture, Ministry of Health, with the slide, it can show that they're acknowledging the camel involvement in this. So some patient, they have contacted camels or not, and the asymptomatic. Yeah. So the reason about this slide is if you look at the asymptomatic cases, it's there. If you look for asymptomatic people, it's there. And the other reason is so asymptomatic cases there. At the peaks of MERS-CoV, those peaks in 2014, 2015, and 16 are related to healthcare outbreaks. So I don't think I can keep up with. I think I will move to the diagnostic part, and they will finish. So there is no vaccine or treatment. And the samples, we have serology or qPCR, real molecular biology. So the serology is only for investigation and research. The PCR is for diagnostic, although it's not yet approved by FDA. The PCR, we have upstream of the EG region as the first PCR, and the confirmatory by overreading frame 1. And then you can do the N sequencing or RDRB. Serology, we have ELISA, we have immunofluorescent assays. They are now commercial, but as I said, they're not for diagnostic. And also serology, looking for antibody, we have microneutralization assay. So basically you have serum for serology, you have RNA for PCR. Serology, if it's positive by ELISA, then you have to confirm it by microneutralization assay or by serotype neutralization assay, and that's a regulation of CDC. Although this is not yet acceptable, but it's found in the research papers. Looking for the antigen, we have capture ELISA, we capture the N antigen, or we have rapid. And the rapid test, the best thing about this is you can go to the field and examine. It's now used for nasal swab for camels. So you swab the camels and on site, you get the result within a few minutes. So I had to go through the presentation, but there is no the diagnostic for MERS-CoV is quite simple until now. There is no revolution or a new trend in the MERS-CoV diagnostic. What I want to say is there is no approved FDA PCR until now, but it's acceptable by CDC, and we need to move on in terms of reporting the data in order to optimize or approve these tests, whether PCR or ELISA or whatever. And one of the things that I noticed on the MERS-CoV, that's the amount of the research that has been done in this country compared to previous outbreaks like Rift Valley fever, for example. If you look at the paper now, there are so many papers coming from this country, which shows that this country is now ready to move on in terms of research. Thank you very much.
Thank you very much. Thank you, Dr. Naif. Is there any questions for?
Thank you, Dr. Naif. I have a question that you might have heard before, which is maybe an immunological question rather than a virological question. Now, there's a general belief that people who are in close contact, if in fact camels are the reservoir, that there are people that are in close contact with the camels and and are asymptomatic or negative. Now, the question is that, is this true? And if it is true, would it be possibly due to similar partial immunity? So what's your take on
Similar
partial immunity? They've been exposed to a similar coronavirus, not entirely the same. They might have some sort of cross-reactivity and partial immunity with the virus.
Yeah, okay. Thank you very much for the question. I think when it comes, I was thinking about this last night when I was preparing the slides for the final thing. I mean, I was trying to see, it's difficult to talk about MERS in general because there are more questions than answers. So we still have more questions than answers. So when it comes to now, there was a paper from Qatar, the same MERS-CoV isolate sequence from human and from his own camels were similar. So we know the virus has transmitted, but we don't know how the transmission happened. So that's first. Second, when you go to shepherds or camel keepers, although there was only one paper from this country, the shepherds has more prevalence of antibodies against MERS-CoV. So there are 3%, if you compare the two sets of data, it's more by 3% in shepherds, so people who are in close contact with the camels. And from unpublished data, we have screened some shepherds, and they are seropositive. Maybe 10% more or less seropositive. But they have never reported any symptoms. That's when you ask about the mild cases. They could be mild, they could get the mild cases or asymptomatic cases, which is I would call this is the missing link between, because those mild cases could go, that's the general belief, by the way. The mild cases from camels go to the community, they spread the virus to more susceptible people, like comorbidities. So yeah, I hope that's answering somehow your question. Is there more?
You said camels are part of our culture. They affect the lifestyle and the economy of a big proportion of people. And they've been accusing the Ministry of Health of bias against camel and camel herders. And this was their argument, that we're with the camels, we never have symptoms, we don't have relatives that have symptoms or our patients. So I think that is the general sense, what you just said, is that the asymptomatic portion of the infected people are those that are driving these outbreaks towards the healthcare facilities that the outbreaks actually occur in. But I'm very happy to hear that there is a greater or a growing body of research generated locally in this regards.
Yeah, and there are 2 points to add here. The asymptomatic, there was a mathematical model published from some people in Jeddah. They estimated there were 2.1 asymptomatic cases in a mathematical model. So that's also a big number. Yeah. And the other thing is the mild cases. When you look at the antibody response in human, you find less antibody in the less severe cases. Mm-hmm. The more antibody, the more severe the